Und jetzt übernimmt Dr. Carolina Plaza-Rodriguez das Wort und hält uns einen Vortrag über Modeling Exposure Risks for Consumers, Differences between Bacteria.
Thank you very much for inviting me to giving this talk. Today I would like to give this talk in English because my German is not so good. Today I would like to talk about the modeling of consumer exposure to resistant bacteria. As you may know, multi-resistant bacteria are widely, for example, ESBL E. coli or MRSA, has been widely detected in livestock animals, for example, in pigs, poultry, and also cattle. And due to the fact that during the slaughtering process, the carcasses can be contaminated through the contact with the skin, with the feces, with the urine or other exudated, also, this multi-drug resistant bacteria has been found in raw meat, including pork, beef, and also chicken meat. Therefore, the presence of this multi-drug resistant bacteria in raw chicken meat at retail has become a major concern of the public authorities. And why? Because we don't know to what extent these resistant bacteria can reach the consumer through cross-contamination and recontamination processes during the household food preparation, and also because we don't know to what extent these bacteria could contribute to adverse health effects, so more important in immunocompromised people. So first of all, I would like to have a brief overview of some important terms. The Codex Alimentarius has defined the risk analysis as a process consisting in 3 elements: risk assessment, risk management, and risk communication, all of them with their overall goal to ensure public health, public protection. The risk assessment plays an important role within the risk analysis, and it consists in 4 elements: hazard identification, hazard characterization, exposure assessment, and risk characterization. There are 2 different approaches to carry out a risk assessment: a qualitative risk assessment and a quantitative risk assessment. The first one, the qualitative risk assessment, tends to be more subjective. Its main goal is to determine the severity of the risk, and normally it provides the results recorded in a risk assessment matrix like the one that we can see in the slide. On the other hand, we have the quantitative risk assessment. It assigns a numerical value to the risk, and its results depend upon the quantity and accuracy of the data that we have. In this case, we apply mathematical models, and therefore we have the option, the possibility to include the variability and uncertainty of our parameters. Here, I provide you with an overview of the quantitative microbial risk assessment process. Depending on the scope and also on the data availability, we can decide which risk assessment elements, in which elements we can use mathematical models. For example, in the first step of the risk assessment, in the hazard identification, we have to identify the hazard, the product, and also the population group that we want to study. In the second step, in the hazard characterization, we will establish the relationship between the hazard and also the population group, estimating the adverse health effect of the hazard in the population due to the presence of this hazard in the matrix. In this case, we could apply those response models. The next step is the exposure assessment. In this case, we can apply process model and consumption model that together will compose the exposure model. Regarding the process model, we want to estimate the probability and also the level of bacteria in the matrix at the time of consumption. In this case, there are several approaches that that can be applied. But in general, we can say that this process model can be divided in different modules that describe one of these simple processes that occur during farm-to-fork chain. That is, for example, microbial growth, microbial inactivation, mixing, partitioning, removal, cross-contamination, or recontamination. In the consumption model, we will calculate the amount of product that will be consumed by the population group, and in the exposure model, we will calculate what is the probability and extent of the consumer exposure to this hazard through the consumption of the product. In the last part of the risk assessment, we will carry out the risk characterization by the join of the different results from the health metric model, dose response model, and exposures model in order to estimate the probability of occurrence and severity of a non-potential adverse health effect in a given population. In the work that I bring it here to you, we decided which was going to be our hazard, in this case multi-drug resistant bacteria, ESBL, E. coli, and MRSA. Our matrix will be chicken meat, and the population of a study will be guests of a barbecue. And why, and not another immunocompromised people? Because it has been demonstrated that in some special situations, like the barbecues, people pay less attention to the hygiene practice. In this work, we will just focus in the exposure assessment. We will not carry out a hazard characterization and a risk characterization. And we will, as a process model, we will apply cross-contamination and recontamination recontamination models. We will not apply consumption model, but we will just define a serving site, and with that we calculate the probability and extent of consumer exposure to multi-drug resistant bacteria. First of all, we have to define our scenario. In this case, we define that the raw chicken meat that is contaminated with multi-drug resistant bacteria is cut into pieces by the use of a knife and a cutting board. Then this cut raw chicken meat is placed into the dish. After that, we use the same knife and the same cutting board that we have used for the raw chicken meat to cut the bread into different slices. And in this case, we consider that in some occasion we rinse a bit the cutting board, and in another occasion we just use the cutting board without rinsing it. On the other hand, the cut raw chicken meat is manipulated, is taken with the barbecue tongs to put them into the barbecue, and once the grilled chicken is ready, we take from the barbecue with the barbecue tongue that we have already used for the raw chicken meat, and place them into the plate, into a dish that we have already used for the raw chicken meat. In this case, also, we, in some occasion, we consider that in some occasion we rinse the dish, but in another occasion we just use directly the plate. At the end, we assume that each person eats just a portion consisting of a slice of bread and also a portion of grilled chicken. Once we have defined our scenario, we have to define the model equation that we want to apply. As we have seen in our previous slide, we consider the cross-contamination of the bread and the recontamination of the grilled chicken. For that, we will use cross-contamination and recontamination model. The cross-contamination model refers to the transfer from a contaminated product to a non-contaminated product via kitchen utensils. And the recontamination model will refer to the food contamination after the inactivation process. That means the recontamination of the grilled chicken. Once we have defined our scenario, we have defined our model equation, we have to define our parameters. We have to parameterize our model. In this case, one of the most important parameters that we have to use for our model are the transfer and persistence coefficients. Transfer coefficients refers to the probability of one CPU to be transferred between different surfaces during the food preparation. And the persistent coefficients refers to the probability that one CPU is still present on an object after rinsing it. For our model, most of the transfer and persistence coefficients were taken from the work carried out by Fetch and Ten Hagen in 2017. They contaminated artificially raw chicken meat and played the same scenario that we have contemplated in our model and repeated it 10 times. At the end, they calculated the transfer and persistent coefficient by using the formula that I have in the slide. So what did they found? They found statistically significant differences between the persistence and between the persistent and transfer coefficient between MRSA and ESBL E. coli. And according to the data, we could hypothesize that maybe MRSA could reach more easily the consumer, because MRSA demonstrate in this work that was able to spread more easily between different surfaces, and also that were able to remain detectable in surface after rinsing. But we have to take into account that the prevalence and concentration rate in raw chicken meat at retail in Germany is much higher in ESBL E. coli than in MRSA. Here I provide you with an overview of the model design. As you can see here, we took into account all the actions and also of the object that was involved in our scenario. And as a parameters, we not only use the transfer and persistent coefficient, but we also use the prevalence and concentration of the multi-drug resistant bacteria in raw chicken meat at retail, and also the chronological order of the action, and also all the gene practice that were carried out during the food preparation. As you can see, our model was divided in 3 sub-scenarios. In the first one, we calculated the cross-contamination of the bread. In the second one, the recontamination of the grilled chicken. And in the third sub-scenario, the consumer exposure. In each of these sub-scenarios, we calculated not only the probability of contamination, but also the level of contamination. That means the number of bacteria that will be transferred from one surface to another. For that, we use, for these 3 sub-scenarios, we use a probabilistic approach. But I would like to remark that in the sub-scenario 2, the recontamination of the grilled chicken, we used 2 different temperatures. So we manipulated the grilled chicken at 2 different temperatures. So that is at 19 Celsius degrees, and after letting the grilled chicken cool down at 60 Celsius degrees. And therefore, using a deterministic approach, we calculated, or we estimated, the impact not only of the hygiene practice, but also of the temperature of the manipulation of the grilled chicken. Here I provide you some technical details on the model design. We use a similar approach like Milus et al. Milus et al. In 2007 used for their cross-contamination model in Campylobacter. As we have seen in the previous slide, we use a modular design. We include as a parameters some probability distribution, and we implement our model in R, applying Monte Carlo simulation. And once the model was ready, we share it in a standardized format, FSKX. Yeah, this is really important because I would like to remark that models at best are only a simplified representation of reality. That means that due to the complexity of the microbial behavior, and also due to the complexity of the food system, we have to apply some technical assumption that could create an underestimation and overestimation of the consumer exposure. So here I provide you just an overview of the most important technical assumption that we took in our model. The first one is that we considered the worst case scenario. That means that, for example, we considered that we didn't we didn't consider that the person who was manipulating the food washed their hands or rinsed them. We also considered that we always use the same utensils for raw chicken meat and the ready-to-eat food, and that just some utensils were rinsed in some situation. Then only raw meat was considered to be contaminated. We didn't consider any other source of contamination. Also, no growth was considered. So we considered that the environmental condition at that time when we were manipulating the food didn't allow the bacteria to grow. So we didn't have to include here any predictive microbial model. We also considered total inactivation of bacteria present on the raw chicken meat after grilling. For calculating the food, so the food we use, the food that was consumed by the consumer, we use surface instead of weight. And we assume always that the person is consumed just a slice of bread and a piece of grilled chicken. Here we have the comparative analysis between MRSA and ESBL E. coli. for the probability of one CPU to be transferred to bread, grilled chicken, and also to the final consumer. Here you can see, for example, that the the cross-contamination of the bread has a higher probability to occur than the recontamination of the grilled chicken. If we compare the average of the probability of one cell to be transferred to the final serving, we realize that, that this probability is 7.6 times higher in ESBL E. coli than in MRSA. What happens if we focus in the number of bacteria that will be transferred to the final serving, or to bread, grilled chicken, and to the final serving in case the raw chicken meat is contaminated? In this case, we can also see that the majority of cells will come from the contamination of the bread, so the cross-contamination of the bread. And as we have seen before, also the number of cells that will be transferred for ESBL E. coli will be 5 times higher than for MRSA. As I said before, we study also the impact of the temperature of the manipulation of the grilled chicken. So this is 60 Celsius degree and 90 Celsius degrees in the consumer exposure. As you can see, the temperature has a big impact in the recontamination of the grilled chicken, and for example, for MRSA, we can see that the probability of one CPU to be transferred is 5 times higher in case we manipulate the grilled chicken at 60 Celsius degree and not at 90 Celsius degree. What happened with the number of cells is the same. So so 3 times more number of cells will be transferred to the grilled chicken in case we manipulate it at 60 Celsius degree instead of at 90 Celsius degrees. What happens if we compare this result from MRSA with the results from ESBL E. coli? As you can see, we have changed the scale of our graphs to be able to compare both microorganisms, and we can see the same pattern. So the probability and the number of cells that will be transferred to the grilled chicken will be higher at 60 Celsius degrees. But as you can see, the impact of the temperature is much higher for ESBL E. coli. What happened with the impact of the hygiene practice of in the probability of one CPU to be transferred? For studying this impact of the hygiene practice, we play different what-if scenario. For that, we vary the default numerical value of the different the probability of occurrence of the hygiene practice from 0 to 1. And the hygiene practice that we consider in this case were the probability that the raw chicken meat is cut before the bread, the probability that the grilled chicken is manipulated with the same utensils that were used for the raw chicken meat, and the probability of the cutting board and the dish to be rinsed. As you can see here, for MRSA, the hygiene practice that has a higher impact in the probability of CPU to be transferred is the probability of the raw chicken meat to be cut before the cutting bread. What happened again if we compare this data with the data from ESBL? We realize that even when we have a similar pattern, we realize that this impact in ESBL E. coli is much higher than in MRSA. We can see also the impact of the hygiene practice in the number of cells that will be transferred to the final serving. In this case, we observe for MRSA that also the probability that the raw chicken meat is cut before the cutting bread plays a major role on the number of cells that will be transferred. But again, if we compare our data with the data from ESBL E. coli, we realize that the impact from this hygiene practice is much higher in ESBL E. coli than in MRSA. So if you want to have more information about this work, you can go to the original publication. There you will be able to find out also a detailed description of the model equation and the parameters, but also you will be able to access to the complete model script. As a conclusion, I would like to summarize the result that we got with this model. But first of all, I would like to remind you that the findings and conclusions that we present in this work are based just on the specific scenario, data, and assumption that we took into account. So based on them, we can say that the probability of the consumer exposure to multi-drug resistant bacteria through the consumption of grilled chicken meat and bread possibly contaminated from raw chicken meat appears to be small. But we have to take into account also that the probability of contamination of ESBL E. coli is 7.6 times higher than for MRSA. Again, for the level of contamination, so for the number of bacteria that will be transferred to the final serving, ESBL E. coli in the case of ESBL E. coli, 5 times more bacteria will be transferred to the final serving in comparison with MRSA. Therefore, based on our result, we can say that the prevalence and concentration of the multi-drug resistant bacteria on the raw chicken meat at retail are the most important factor on the consumer exposure to resistant bacteria. And also that the higher the prevalence and concentration, the greater the impact of hygiene routines on the probability and extent of consumer exposure. This has some consequences. For example, we should remark that effort to reduce the use of antibiotics by improving the animal health must be further intensified in order to achieve a reduction in the resistant rates in this raw meat at retail. Also, it's really important that compliance with good manufacturing and hygiene practice in slaughterhouses and processing plants, and what can we do at home? At home, we should have a strict adherence to hygiene measures during household food preparation, for example, handling raw meat properly, using different kitchen utensils for raw meats and ready-to-eat food, washing hands and surface between different steps of food preparation, heating meat thoroughly, and also taking into account that raw food of animal origin should be not consumed by immunocompromised people. If you want to have some tips on kitchen hygiene, you can visit our website. And before I finalize my presentation, I would like to thank all the people that has been involved in this work in their different roles, data provider, data analysis supervisor. Thank you very much to all of them. And that's all. Thank you very much for your attention. If you have any questions.